Hello viewers at home. You are tuned to yet another edition of e-learning program organized by Kebbi State government in order to keep students academically busy at home during this COVID-19 stay-at-home period. My name is Mohammed Sani Kele. I am your teacher for physics. So, physics. Children what? Physics. In our previous lesson, we've learned about force, where we said energy is force multiplied by distance. So force brings about something. We said force is a kind of a push or a pull on a body. So force of a pull brings about what we call motion. So the tendency of an object, today we are going to study motion. The reason why I said force is because you cannot have motion without force. So I'm linking you with what causes motion. So our topic is going to be motion. Motion. Motion is defined as the tendency of an object to change position from rest. The tendency of an object to change position from rest. Look at this. This is in rest. So if this one is moving, it's doing what is called motion. And it cannot move, remember, without a force. So you either push to obtain a force, or you pull, a motion, or you pull to obtain a motion using force. So let me define motion. Is defined as the tendency of an object to change position from rest state, from the state of rest. Motion is defined as the tendency of an object to change position from rest state. Look at it. Look at it. This is an object. Here it is in rest state. So if this object is changing position, what am I using? I'm using force, pushing force to move this object. And this is motion. So motion is the tendency of an object to change position from rest state. And remember, children at home, you cannot have motion without force. Force is the cause of motion. So, types of motion. We have basically 4 types of motion. Number 1 is translatory. Translatory motion. Number 2 is circulatory. Circulatory motion. Number 3 is oscillatory. Oscillatory what, viewers? Oscillatory motion. And then number 4, we have random motion. Right? So before I explain these types of motion, let me give you alternate names, alternative names of these motions. Translatory motion is otherwise called linear. Linear what? Motion. So don't get confused. So that you don't say, I only saw linear motion, I have not seen translatory motion. They are the same. Translatory motion or linear motion, they are the same. Circulatory, rotatory motion, please. You either say circulatory motion or rotatory motion. Oscillatory motion. Oscillatory motion has another name also, vibratory. Oscillatory, vibratory motion. Vibratory what? Motion. Viewers, are we learning? Right. So random motion. Random motion is otherwise called zigzag. Please. Zigzag motion. Zigzag what? Motion. Are we learning? Right. So these types of motion are different, distinct from one another. You see, let me start with translatory motion or linear motion. Translatory motion or linear motion is the motion of an object in a straight line. Translatory motion is the motion of an object in what? In a straight line or direction. For instance, a body, e.g., a body starting from rest position. Let's say this is A, position A, and then moving to position B. A body starting from position A moving to position B here is doing what is called translatory or linear motion. So this is an example of what? Linear motion, please. Linear motion, please. Are we together? Right. So, as I said, example, the day-to-day example is when you move with your bicycle from home to school, you do a kind of translatory motion because you are going on a straight line. You are not bending. So it's one of the examples of what? Translatory motion. Circulatory motion is number 2. In a circular, please, from the name, circulatory, circular manner, please. Circular manner. If you climb your bicycle and you are going about a roundabout, going round the roundabout, you are doing a kind of circulatory motion. Circulatory what? Circulatory motion. So let me give you another example. This is what? This is what we call pendulum. Look at it. Look at it. Sorry? Look at it. This pendulum is doing what is called circulatory motion. Another example is the motion of your ceiling fan. Children, the motion of your ceiling fan is another example of circulatory motion. I want you to think of several other examples of circulatory motion there, so that you can feed me back. You can tell me what you've got to learn. Please, number 3 is what? Children, what? Oscillatory motion. Oscillatory motion in a to and fro manner. Please, to and fro manner. To and fro manner. To and fro manner. This one I forgot to put a cycle. So you have motion like this. Sorry. So a body starting from A and then going through to get to point A again. That is a circulatory form of motion. Now, oscillatory motion. Oscillatory motion is the motion of an object. Look at it now. If this is the motion of an object where its acceleration is directed, look at it. For example, this is point A, point B, and point C. Let's say this is A. This is B, and this is C. So, if this is an object starting from A, moving towards B, and then passing to C, and then coming back from C towards B to now A, is doing what is called oscillatory motion, please. Oscillatory motion, I want to also demonstrate it using this pendulum. Look at it. Look at it. Look at it now. Look at it. This is rest position. Do we have motion here? No. There is no motion here. But look at it. Let's say this is position A. This position A is here. I'm releasing this to go to position B and C, and then coming back to position A. Look at it. Look at it. Look at it. Go to and fro motion of an object. This is an example of what? Oscillatory motion. When they ask you what is an example of oscillatory motion, you can say the motion of a simple pendulum. Children at home, do you know seesaw? The one they climb in our school, in our primary schools, and they push you and you go and come. Is one of the examples, several examples of what? Oscillatory or vibratory motion we have. So I want to use also this one, because sometimes people misunderstand oscillation misplace oscillation. They say oscillation and vibration are two different things. Look at it. Look at it. This one is also vibratory motion. Look at it. To and fro movement. This is vertical while the other one is horizontal. So they are the same. They are what? The same. This is vibratory or oscillatory motion, please. So the fourth and the last one is what? Okay, viewers at home, you can check out there for many other examples of oscillatory motion and all other types of motion. You can think about them at home in our day-to-day activities. Then number 4 is the random motion. The what? The random motion. The random motion is also called zigzag motion. Zigzag motion, please. Motion of an object without specific direction. Motion of an object without specific direction. So, a body starting from point A, going this way. So, this body is doing what is called random or zigzag motion. So, zigzag motion can best be explained by a housefly. You see how a housefly behaves in home. It will go this way, go this way, go this way, anyhow. It doesn't have a specific direction. So that is an example of what? Random motion. You can think of other practical examples of random motion out there. So, so these are the types of motion we have. So, viewers, remember I said the cause of motion is a force. There is no motion without what? Without force. Please, always put it at the back of your mind that you can only have motion where there is force. So, a force causes motion. So, and these motions are classified into 4 types. So, we have translatory or linear motion, we have circulatory or rotatory motion, we have oscillatory or vibratory motion, we have random or zigzag motion. So these are the 4 types of motion we have. So next is so viewers, we are going to further go into equation of linear motion. Equations of what? Equations of linear motion. Please, I'm going to reserve this for our next class, because it involves a lot of numerical explanations and computations. So, meanwhile, I want to remind you to strictly adhere to the do's and don'ts of the NCDC. Please stay at home to stay safe. Please make good use of the opportunities you have to learn from this e-learning program. I want to drop my phone number so that if you have anything to demand from me, you can do that through my phone number, through text message or WhatsApp message on this number, 08036843963. 8. Please adhere strictly to those do's and don'ts of the NCDC. I also repeat it and say it again and again. Wash your hands with soap and running water. Please stay at home, avoid crowded places, and then concentrate on this e-learning program. Thank you very much for watching. Thank you.